Hello there, young students of chemistry. This is a quick recording about the general types of mathematics that we use in chemistry class. And what I'd like to do first here is to have you, let's see where your algebra skills are. If we look at the problems that I have listed here in the notes, this is stuff I expect you to come in already knowing how to do and to do it consistently correctly. So take a few minutes and pause the recording and solve these problems for the variable that they're asking you to solve for. Okay, so here's the answers to the first three. You should check your work and know that when you are isolating a variable for problems such as those three that I've written for you, if you got those wrong, you are pretty deficient in your math skills stepping into honors chemistry. This is something that, when we're doing this kind of algebra, you should be able to solve for these easily and even in your head. So just know that that doesn't mean it cannot be overcome. It just means that you're starting out in a place that is less than where you need to be when you come in the door. So it's going to require a little bit of extra work on your part. So on the next one, solving for V, this is where students sometimes will fall apart here. So I'm going to show you just really quickly, just one time, the problem-solving process when you have a variable on the bottom of a fraction. So when you have a fraction, D is equal to M over V, I'm just going to make a fraction on both sides. It's easy to make a fraction out of density by putting it over 1. The problem-solving process, when you have fractions and you're solving for a variable, is called cross-multiplication and division. We are going to cross-multiply, meaning we're going to do numerator times denominator equals numerator times denominator. That's called cross-multiplying. So we end up with dv equals m times 1. Now the rest of that process, cross-multiplication and division, the division is for isolating the variable that you need. We want to isolate the v variable, so we have to divide both sides by d to isolate the v variable. So the equation is v is equal to m divided by d. You really need to be at the point where you can do those things in your head. So again, if we used cross multiplication and division for P1 on the next problem, P1 equals V2 P2 T1, cross multiplied, dividing by V1 T2. Same thing here under T2. T2 is equal to V2 P2 T1 divided by V1 P1. And then solving for x, x is equal to 4 point, put that away. X is equal to 4.48. So here where students make a mistake is that they don't understand that 2x squared times x is not 3x squared. 2x squared times x is 2x cubed. If we were adding those, it would be 3x squared, or 3x actually, plus 2x squared. So, but when we multiply like that, what we end up with is 3x squared. Oh, booger, I just told you that's not what it is. I got all confused, sorry. So 2x squared times x is 2x cubed equals 180. So if we isolate the variable x, we have to divide 180 by 2 to isolate the x cubed, and then to isolate the x, we're going to take the cubed root of that. X is equal to 180. So this is the kind of algebra I expect you to do. So keep in mind that if you cannot do this kind of algebra now, you're a little bit behind and you're going to need to spend some time getting your mathematical skills up to par here. Okay, the other way that we solve problems in chemistry is by using something called dimensional analysis, sometimes called the factor label method. Either way, what we're doing is we're making fractions and we're multiplying fractions to each other, right? Multiplying fractions. And this process, the reason it's called dimensional analysis is because the units give us the dimensions of the measurement. What we are doing is analyzing units. You have to use a unit to use this problem-solving process. It is unit-driven, not number-driven. So anytime you have some measurement that has a fractional unit, this measurement here is called molar mass. For water, that is 18.02 grams per mole. That's how we read that fraction, per. And we know that that per assumes 1 mole. So it is 18.02 grams per 1 mole. We know that density, grams per milliliter. And then there are some other equivalents. You know, we will use SI conversion factors tomorrow, or SI prefixes tomorrow. And then there's just some things in life that you know, like 12 is equal to a dozen, 60 seconds is equal to a minute. But if we have any of these, we can make 2 conversion factors from the one equivalent measurement. So with 60 seconds is equal to a minute, we can say 60 seconds per minute. Or we can say 1 minute is equivalent to 60 seconds. So these would be the conversion factors that we can make from the equivalent. Now, the equivalent, the conversion factors, which the one you choose to use, depends solely on what unit that you want to cancel. And remember that something that is on the top of a fraction and also on the bottom of a fraction, that cancels out. So we can see that if we wanted to cancel the unit minutes, we would use 60 seconds over minutes. If we wanted to cancel the unit seconds, we would use 1 minute over 60 seconds. Let's do a few of these together using this density of aluminum here, 2.7 grams per centimeter cubed. From that, we can make 2 possible conversion factors. That would be 2.7 grams for 1 centimeter cubed. That's the way it's currently written. Or we could say 1 centimeter cubed of aluminum has a mass of 2.7 grams. Both of those are correct statements. The thing you need to remember is that you cannot lie. You have to use a correct statement. So if we're solving this equation, we're going to take what we're given and we're solving for grams. So the unit we're starting with is centimeters cubed. Put your given over 1. I'm actually not going to write that. I think it makes it look messy. We're going to multiply it by a fraction in such a way that centimeters cubed cancels and grams stay. So we're going to use the fraction, our conversion factor, that has the centimeter cubed on the bottom. And that's the first one that we listed. We can see that centimeters cubed cancel, and that gives us the unit gram. So now all we have to do is chug it out in our calculator. We are in effect multiplying 40 times 2.7. That's going to give us 108 grams is what the calculator gives us. Please remember that whenever you do a calculation, you have to put your answer to the proper number of significant digits, which in this problem is 2, based on the 2.7. So our 108 grams is not a correct answer. It is 110 grams. When I personally am grading these problems, it is 1 point for the conversion factor and then 1 point for the answer. I do not give you a point for putting the given over 1. You know, I expect you to be able to make a fraction out of that, and you're not really doing anything there. So if we look at this again, on the bottom we're starting with grams. We're solving for how much space. How much space is a measurement of volume. The unit for volume here is centimeters cubed. I would expect you to get that from your chapter 3 reading. So if we've got mass, grams, we want to cancel grams. So gram needs to be on the bottom, centimeter cubed on top. The relationship is that there's 2.7 grams for every 1 centimeter cubed. So this time we are in effect dividing. We can see that grams cancel. That gives us the unit that we want, centimeters cubed. 40 divided by 2.7, and then expressed to 2 significant digits is 15 centimeters cubed. Okay, I'm going to go a little bit faster on the next ones, and then you need to complete the notes in your binder. So here is some information about water. This last one applies to all substances, but all of these other measurements refer to water specifically. I want to rewrite this heat of fusion a little bit to 40,650 joules per mole. So all of these measurements have fractional units, and because of that we can make 2 conversion factors out of them. So if we look at the first one, 40 grams, we're solving for moles. It says equals how many moles. So what you're going to do is look to see, do we have a conversion factor that has both moles, what we're solving for, and grams in it? And we actually, on this problem, do. We have the molar mass of water. So here we want grams to cancel and moles to stay. So grams go on the bottom, moles go on the top. We can see that the 18.02 applies to the gram and not the mole, so the 18.02 goes on the bottom. And then again, we are in effect dividing those numbers. So we've got 3 significant digits on the 40.0. 18.02 has 4 significant digits. We always report to the least number of significant digits. So we will report here 2.22 moles. Okay, and if we look at the next problem, we can see that we are starting with the unit milliliters, and we are going to the unit molecules. So if we look at our conversion factors, we can see that we do have a unit that has milliliters in it right here, but we cannot get to molecules with that. We can only go from milliliters to grams. So we're going to have to use more than one conversion factor. So let's start by canceling the milliliters. 80.4 milliliters over 1, just making a fraction. And we know that we want milliliters to cancel and grams to stay. And then the number is 0.9994, and that number is affiliated with the unit gram. So we have done something. We haven't solved the problem by any means, but we have done something. We have canceled milliliters. Now what we need to do is cancel the grams. So let's look at our measurements that are available to us and see, okay, is there anything that will allow us to cancel grams? So we've already used the density, and if we look at these, the only other unit that has grams in it is this one, the molar mass. So we will cancel the grams using the molar mass. Gram on bottom. Molar mass allows us to convert between grams and moles. Gram on bottom, mole on top. The 18.02 must stay tied to the unit gram. Grams cancel, and now we have the unit moles. Again, we've done something, but we have not solved the problem because the problem is asking us for molecules. So the only other measurement that we have that contains a molecule is this measurement here, which is called Avogadro's constant. 1 mole is equal to 6.02 times 10 to the 23rd molecules. So we go back to our conversion factor. We know that we want moles to cancel and molecules to stay. I'm going to need more space. My abbreviation for molecule is MOLEC. That is my abbreviation. That is not a universal abbreviation. So we can see that the 6.02 times 10 to the 23 has to go to the unit molecule. And then we are going to multiply. Now we have the unit molecule. We are done. Moles cancel. We have the unit molecule, and the problem is asking us to solve for molecules. So now in your calculator, 80.4 times 0.9994 times 6.02 times 10 to the 23rd divided by 18.02. And we are getting 2.8 times 10 to the 23rd. Actually, let's check significant digits. We need 3 significant digits, so 2.80. Listen, if you did not get that in your calculator, you need to see me about how to use your calculator appropriately when you have a number that is written in scientific notation like that. Okay, your job now is to do the next 3. So you have 3 here, and you should do those and then check your work with me. Okie doke. Thanks for listening.